What's up, Algebra 2? Here we are with solving by elimination. Should be another review unit from Algebra 1. And our first problem that we're going to do today has it already set up perfectly for elimination. This is the situation that we are trying to get. One variable that has matching coefficients but opposite signs. Minus 3y and a plus 3y. Because we add down, and when we add these down, we'll get 6x, and then our y's will cancel. Minus 3y plus 3y is going to be 0y. It's going to cancel out or eliminate. And then negative 22 and 16 is going to be negative 6. Divide both sides by 6, and we get x equals negative 1. Now, just like substitution the day before, we're going to take whatever our first value is, we're going to substitute that back up here. But this time, since we didn't use one of these lines to substitute into the other one, you get to pick from either one. So it doesn't matter. I'm going to go with this one because it looks smaller. 2x, 3y, 16 looks smaller. So I'm going to put that negative 1 in there. But you can pick from any of the equations up here. So 2 times negative 1 plus 3y equals 16. Plus 2, plus 2. And we'll have 3y equals 18. Divide by 3. Y equals 6. Put them both together for our coordinate point, negative 1, 6. Okay, that's like the easiest type of problem with elimination when one of the variables is already set to cancel out. You just have to add down. Sometimes you might have to multiply one equation or one line of the system by a number to get that to happen. Sometimes you have to multiply both lines by a number to make that happen. After you have it matched up to where they would eliminate, we're going to add down, hopefully eliminating one of the variables, solve for the one that's left, and then substitute that answer back up into any of the equations and solve for your last variable. All right, let's do some more. Top left problem is not good to go right off the bat. You're going to have to do some thinking, hopefully not too much. The 5x and 2x, nothing very easy there. But what we like to see is just a single one, like a single y or a single x, because then you can just multiply that row by whatever you need to make it match up with this one. So this is just 1y, that's minus 3y. They're already opposite signs, plus minus. Okay, so I just need this to be a 3y. So we're going to multiply that whole row by 3. And that will give me, I'm going to write it just right underneath of it here. 6x plus 3y equals 21. Scratch that out. And we will add down. 5x plus 6x is going to be 11x. Minus 3y plus 3y cancels out. And then we'll have 44. Okay, let's divide by 11. X is 4. Now, we have our choice of any of the equations, including our new one. So now we technically have 3 equations to pick from that you would think would be easiest to substitute that 4 back into and solve for y. So I did a light scribble through that one after I multiplied. I did a light scribble through it so I could still see it. And I think that was the easiest one to use because it's 2x and then it just has a plus y. So it'd just be a single y equals ready to go. So I'm going to go 2 times 4 plus y equals 7. So we should have 8 plus y equals 7. Subtract that 8 over. And we'll put our point together here. 4, comma, negative 1. Alright. So we had to multiply one line by 3 in order to get a 3y to cancel out that negative 3y. And then we added down, solve for x. We had our choice of any of the equations up here to substitute x back into it and use that to solve for y. Now the tough one. And it's just long, it's not really tough. Okay? So we have 6x plus 5y and 5x minus 9y. There's not one easy one, right? There's not a single x or a single y that we just have to multiply something by to make it match. There's no number I can, without going into decimals, there's no number that you can just multiply this line by to cancel out with this, or this line by to cancel out with that. So we're actually going to need to, what I call meet in the middle, multiply both of them to meet somewhere. Okay, and what usually that means is you're just going to trade. So if you want to cancel out the x's, you're going to multiply the top row by 5 and the bottom row by 6. Okay, for the x's there, one of those numbers would have to be negative. For the y's, they're already plus minus, so we don't have to worry about any negatives. And you would multiply the top row by 9 and the bottom row by 5. So we have some choices to make. 5 and 6 is smaller than 5 and 9, and you'd have slightly smaller numbers to work with, but you would need to make one of them be a negative. And it's really easy to make a mistake with losing a negative when you're transferring that to, or distributing that to all 3 parts. 5 and 9 are already plus minus, so you don't need to multiply any of them by a negative, but it will be slightly bigger numbers because you're going to be multiplying by a 9. So, there's no wrong way to go, it's just your choice. Today in class I've been going with using the 9 and the 5. So I'm going to multiply the whole top by 9 and the whole bottom row by 5, and that should hopefully give me 45y and negative 45y, and those will cancel out. Okay, if you have small handwriting or neat handwriting, I'm going to try to squeeze it in over here on the right. If you have big handwriting, you might just want to jump down to underneath of those. Okay, so we take that 9 to all 3, and we'll have 54x plus 45y equals negative 288. I've done that 5 times today, so I'm pretty confident in that 9 times negative 32 being negative 288. Okay, this time we're going to take that 5 to all 3, and we should get 25x minus 45y, and that's going to be a positive 130. And now we should be ready to add down, and we're going to cancel or eliminate our y's. Plus 45y minus 45y is 0. Our x's will have 79x, and negative 288 plus 130, we're going to have negative 158. Divide by 79. X equals negative 2. Okay, now we actually have 4 options to plug that back into. The 2 new ones and the 2 original ones. Okay, so if we're thinking about plugging this negative 2 in to one of the x's and then solving for y, I don't think I want to use these two because that has 45y at the end. That's going to be a big number to divide by. Okay, I think I'd rather maybe plug the negative 2 in here and then end up dividing by 5. Dividing by 5 doesn't seem like it's too bad. So I'm going to put it into that first one. So I'm going to have 6 times negative 2 plus 5y equals negative 32. So that's negative 12 plus 5y equals negative 32. Let's move this over. Add 12. y equals negative 32 plus 12. That's going to be negative 20. And then here we are dividing by the 5. Not bad at all. Negative 4 for y, and then your coordinate point should be negative 2, comma negative 4. Okay, so a little bit tough up here, getting them to match up and cancel out. After that, it's the same stuff we've been doing. Okay, these bottom 2 are special cases. You're going to do the elimination process, but it's still going to be the same scenarios as the substitution from yesterday. So go ahead and push pause and try both of those. I think they're both medium ones, not easy or the hard. But they should both be mediums. And see if you can remember the 2 situations there. Go ahead and push pause and give those a try. Okay, welcome back. Let's see how we did with those. Okay, I'm seeing a 1y and a 4y. So I'm going to try to cancel the y's here. And I'm going to look at doing a negative 4 to the top row, thinking that that's going to give me negative 4y to cancel out that plus 4y. Okay, and we do have a free line above it, so you could go up here, or you could just go down below. So negative 12x minus 4y, negative 48, and we'll cross that out, just a light one there. And look what happens. We were trying to cancel out the y's, and we're actually going to cancel out everything. 12x minus 12x cancels out. 4y minus 4y cancels out. So that's 0 on the left. 48 minus 48 is 0 on the right. 0 equals 0. That's a true statement, which means we have infinite solutions. So that one was the infinite solutions one, which probably means the next one is no solutions. Let's take a look over there. Okay, I see a negative 1y and a negative 3. So that's probably the easiest one to match up. Maybe you see this one, 2x, and you're going to multiply it by a negative 3 to cancel out 6x. Either way, let's take a look. We're going to multiply this one by negative 3. Negative 6x plus 3y equals negative 33. A little light scribble. Don't want to totally scratch it out, just in case we need to go back and take a look. 6x minus 6x cancels. Negative 3y plus 3y cancels. We got 0 on the left. 30 minus 33 is negative 3 on the right. Does 0 equal negative 3? No, that's not true. So we have no solutions. Okay? And in case you forgot from the previous lesson, what that looks like is that these are literally the exact same line. If you can look here, you can see that this is literally just 4 times the one above it. So it's literally the same line. So it's going to be, there's the first line, there's the second line right on top of it. They share all their points, so it's infinite solutions. This one's pretty close, but they have different C values. So it's going to be like this, parallel lines. It's going to end up having the same slope ratio here of x and y, but we have different C values, so they're going to be off, and they're not going to be overlapping. They're just going to have the same slope and never touching. So there is the notes for elimination. All right, thanks for watching. Let me know if you have any questions, and good luck on that homework.